So this is the exciting part about all this differentiation. Is actually allowing us to see what we cannot see using regular graphing calculators. I'm sure this is the first time in your life that you hear about an equation like this, and yet we have to find the slope of the tangent line to a graph that we've never seen. So the beauty of this algebraic part is that we can actually find it without having no idea what this curve looks like. Isn't that amazing? I feel like the Cyclops. Anyhow, the graph of this curve appears on the book, and I tried to reproduce that without success, but you're gonna get the idea. This is called the volume of the K. I'm reading it right. It's a French word. I don't know any French, but anyhow, it's the combination of three functions of x. The same idea with a circle where you have two functions into one. In this equation, we have three functions into one. So knowing that, then it is easy to understand why we can take the derivative of a function like this. But if we didn't know this fact, then you will say, well, this doesn't pass the vertical line test, so how come we are doing all these things about something that is not a function? But it's 3 into 1 because we need to do things bigger and faster. So again, I can solve for y, so any of the methods that I've learned how to take the derivative are obsolete in this case, but we can use implicit differentiation, and just remember that y depends on x. So this y depends on x, and if you see it somewhere else, that one also depends on x. Okay, so we have two that depend on x. So I can use the Leibniz notation dy over dx, which is fine, or if you want to use the prime notation and write y prime, that is fine too. Let me do the first line on the Leibniz notation, and then if you want to switch to y prime, that's fine. I will switch to y prime just because you can write it faster, and faster is better. No, not always, but in this case it is. Okay, so take the derivative of sum is the sum of the derivatives, and I'm going to take the derivative of the right side, which happens to be only one term, like 6xy, that's one term, and everything with respect to x. This one is easy, 3x squared. This one is the one that you have to be careful because y depends on x, so there's going to be an extra term, 3y squared and dy over dx using chain rule. And then this one, very careful, it may not look like it. You may want to say it's just 6y or 6x or 6, but that's not the case because this is a product, and the first function is 6x and the second function is y. So product rule, ladies and gentlemen, derivative of the first one, which will be 6 times the second one, plus the first one times the derivative of the second one, which is a function of x. So derivative of y is 1 times the derivative of y respect to x. Now I'm gonna switch to prime notation just because it's simpler to write. 3x squared plus 3y squared y prime equals 6y plus 6x y prime. And now I'm just gonna rearrange it to factor y prime. So I noticed that a 3 goes into every term, so I will factor that out. And then if I factor out a 3 out of here and a 3 out of here, they will cancel out. So I can divide the entire equation by 3 if you want to think of it that way as well. So then I'm grouping the terms with y prime on one side of the equal sign, and then I'm factoring out the y prime. So now I find the derivative of my function, which depends on x and y coordinates. So for whatever my graph is, well, I know how it actually looks like, but let's say that I don't. For any point x, y, I know that the tangent line has a slope of the x-coordinate square minus 2 times the y-coordinate, everything divided by the quantity double of the x-coordinate minus the y-coordinate square. Now, in a multiple choice, this may be one of the options, or its equivalent, and you can obtain that. Let's say that I wanted my y primes on the left side of the equal sign, then I'm going to have to subtract by 2x y prime, and in here I will have to subtract by x squared. So the equivalent form of this would be if I have the minus signs reversed, like negative x squared plus 2y over negative 2x plus y squared could be an option. And also its equivalent, maybe I don't want to write it as a sum, maybe I want to write 2y minus x squared over y squared minus 2x. As long as I reverse the order on the subtraction on the top and the bottom, then I still have the same fraction as a value. So just be careful whenever you're solving something like this. You may not find the exact answer the way you see it. You may find its equivalent forms. This is just the same way as saying, you know, I have 3 minus 1 over 5 minus 2. This would be 2/3, right? 2 over 3. This is just the same as saying 1 minus 3 over 2 minus 5. This is still positive 2/3, because negative over negative would be still positive. And also we've done that with average velocity. Whenever you were supposed to find average velocity, you just have to keep the order of the points. It doesn't matter if you do y1 minus y2 over x1 minus x2, or y2 minus y1 over x2 minus x1. So everything is the same if you switch, as long as you switch both. So a natural question following up our result, definitely finding the equation of the tangent line to any graph, in this case to the volume of the curve at the point 3, 3. So I acknowledge that x is worth 3 and y is worth 3. So using our formula for derivative that we just found, I'm going to use the one that I had as a result, just to show you that if you compare this answer, I think it was 2x, if you compare this answer to the one in the book, it matches the same. So it really doesn't matter in what order they are, as long as you know that it's equivalent. So please don't start changing the terms in a subtraction just for no reason. I'm doing it because it's the same thing in the numerator and denominator. Okay, so I'm gonna replace x was worth 3 and y is worth 3. I don't like this kind of examples where you have the same x and the y, because then whenever you see it, people don't know what it is that you were doing. You may think that you always replace it with the same number, when that's actually not true. It just so happens that x and y match, but only in this case, please. Okay, so I'm gonna find this. This is 9 minus 6, which is 3, and this is 6 minus 9, which is negative 3. So the slope is negative 1, and then naturally the equation of the line using point slope, y minus 3 equals negative of x minus 3, and that will be my beautiful equation. Now for part C, they're asking us at what point in the first quadrant. Okay, so we're only gonna stick with the first quadrant. The tangent line is horizontal. So remember, what is the interpretation in terms of derivatives of this? This would mean I want to know when y prime is 0. Okay, so I have my equation. Y prime equals x squared minus 2y over 2x minus y squared, and I want to make that equal to 0. So the only condition here that you have to watch out for is to make the numerator 0. And be careful, you don't want to make the denominator 0 as well. So I'm going to show you how that comes to into consideration. But you know, the first thing to do, I just want to equal my numerator to 0. So I do that, and then I see that, let me just lower this, that y equals x squared divided by 2. So what does this mean? I didn't find an x or a y, but I know a relationship between x and y. And the other thing that I know between x and y is that x cubed plus y cubed equals 6xy. So I'm going to replace this fact into this equation. X cubed plus y, let me just write it out again for no reason. Now I'm going to replace it. X squared over 2 cubed equals 6y x squared over 2. So whenever I see y, I replace it with x squared over 2 so that I have one equation with one variable, which is perfectly solvable. One thing that you have to pay attention, the entire quotient is raised to the third power, so don't forget to raise to the third power the numerator and denominator as well. So let the magic happen. Okay, so I raised to the third power this quotient. It gave me this. 6 divided by 2 is 3, x times x squared x cubed. I group the x to the third power because they are like terms, and I made my equation equal to 0. And then I factor out an x cubed. Now that I have these two factors equal to 0, then each factor may be 0. But x cubed being 0 makes x equals 0. But remember that from my derivative here, this denominator cannot be 0. And if x is 0, y is 0, and this quantity will be 0. So since this has to be different from 0, then this is really not an option. So I'm just going to look at what is feasible. So then this factor has to be 0. When I solve for x, I have x cubed equals 16 because adding 2 both sides and then multiplying by 8 both sides. And then I have x equals 16 to the 1/3. So I'm almost done. The point that I'm talking about has x coordinates 16 to the 1/3, and then I get the y by replacing it into this equation. Naturally, you want to replace it here than in here. So so when I do that, it would be y equals x, which is 16 to the 1/3, square over 2, and that will be 16 to the 2/3 over 2. Remember that when I have exponent of exponent, they multiply. 1/3 times 2 is 2/3. So this will be my answer, and it will be fine as a number. That's what I have. But if this was a multiple choice, then you may not see this answer, simply because 16 is a multiple of 2, is a power of 2, so I can simplify this out, and it will be as follows. The only thing I have to remember is that 2 to the 4th is 16, so I replace that everywhere I can. So the point, this point is just the same as saying 2 to the 4th to the 1/3, and the y coordinate will be 2 to the 4th to the 2/3 divided by 2. Okay, so now that I have all powers of 2, let me just simplify a little bit more. I know that exponent of exponent, I have to multiply it. I'm sorry, when I have power of a power, I multiply the exponent. So I have 2 to the 4/3, and then I have here 4 times 2 is 8, 8/3 minus 1, that will be 5/3. So your answer in a multiple choice, you may find it like this, or you may find it like this, but either way, it is just the same quantity. So this is mathematically correct. This is also correct, but you know, it depends on whoever wrote the questions, what is the best answer.